You know, we keep on fighting network from this end. So you will always be patient whenever you join the GMAETS 41's class, streaming from here. In this country and of course location, it's not always easy. Sometimes network would really disturb us. But I'll always try to see how I can boost it. There's something I usually do to boost network. So let's see. I hope you're connected back now, because I observed that network stressed or disturbed a moment ago. So like I was saying, if you follow up with the GMAETS 41's work, we are always ahead so as to prepare you, okay, ahead of your school works. It can always count on the GMAETS 41 because our strength comes from our God and helper Jehovah. Physical quantities and their units. When talking about physical quantities and their unit, what is our focus? So at the end of this class, you should be able to identify the two major types of physical quantities that we have. Be able to define these physical quantities, and of course, you should be able to state their System International Unit, that is SI units. Once you're able to do this, I think that's sufficient. That's really what you're meant to focus on this topic. So we're going to start with what quantities are. We are going to start with what quantities are. Like I said, network can always make me go check what is happening, you know, in the camera there, because this device seems to hang sometimes because of network challenge. Is that okay? All right. So when we talk about physical quantities, first of all, I want to understand that physics is a branch of pure science that deals with quantity measurement. Physics is a branch of what? Science that deals with physical quantities measurement. That is measurement of physical quantities. No wonder when you come to the field of physics, there are various branches of it, ranging from things that had to do with mechanics, right? Basic aspect of physics, we now start skyrocketing. You know, we start growing, we start moving up, and then we start discussing things that has to do with, you know, the celestial bodies. Yet, you know, the concept of astronomy comes in, and astrophysics, geophysics, and many other. One of the major things a physicist is interested in is to measure quantities as related to the universe. So you want to bear this in mind. Although generally, no one would really ask for definition of physics, but I've been able to point out to areas in which, you know, physics branches into. The very first thing, like I said, is for a student to understand what quantities are, the types of quantities. Okay, so we're going to quickly talk about the two major types of physical quantities. There are two major types of physical quantities. A physical quantity can either be fundamental, which we call base quantities, or a physical quantity can be derived quantity. There are two types of quantities, like I said. We have fundamental quantities, fundamental quantities. Fundamental quantities, like I said, are also known as base quantities. Base what? Quantities. Yes, we call them base quantities because for any science student, I repeat, for any science student, you don't play with these fundamental quantities. They are the base, they are the foundation, the beginning of quantities that physicists study, scientists study. They are the base, the foundation, all right, the fundamental, the beginning. It is from these fundamental quantities that we now have the second type of quantity called derived quantities. Derived quantities. So a quantity can either be fundamental, which is also the same as base, or a quantity can be what? Derived. Like I said, fundamental, they are the beginning of the study of quantities. And then like you have the second type of quantity, derived. The word derived means originated, obtained from, gotten from. So when you talk about derived quantities, these quantities are obtained. They are gotten from somewhere. And where do we get them from? We obtain them from fundamental quantities. So what have we learned so far? Just from the beginning of this class, we have established the fact that there are two major types of physical quantity. A quantity can either be fundamental quantity, also known as base quantity, or a quantity can be what? Derived quantity. And we have established that fundamental quantity are the base quantity. They are the foundation of quantities, the beginners of quantities, right? Whereas derived quantities are obtained from fundamental quantity. Having given this lay interpretation, simple interpretation to these types of quantities, we are going to define them now. We're going to define fundamental quantities and as well define derived quantities. Then we'll now look at their units, their SI units, which are standard values attached or given to these quantities. In fact, I call them surnames, all right? Units. But we're coming to that. Let us define what fundamental quantities are and what derived quantities are. Fundamental quantities. These are quantities that do not depend on other quantities for their definition or derivation. Quantities that do not depend. They don't need other quantities to define them. They don't need other quantities to derive them. They are on their own. They are unique. They are the originators, the beginners, the foundation of quantities. So any quantity that does not depend on another quantity for its derivation on fundamental or base quantity. Please a moment. Let me check the network situation through the camera. Be sure that you're still connected. Good. You're there. All right. So I've been able to define fundamental quantity. Remember, you can put this down. You can always put it down. Should be able to write dictation. When someone defines, speaks, says something, you try to put down some important point from the person's speech or statement. We have defined fundamental quantities. Quantities that do not depend on other quantities for their what? Derivation or for their definition. Which means if you want to define them, if you want to define fundamental quantities, you don't need other quantities to help you define them. Or if you want to derive fundamental quantities, you don't need other quantities to the network seemed to really be down, Please reconnect back. Like I said, you want to be patient whenever the network interferes. Don't log out. I would always find a way to boost the network so that you can connect back. Please, I want to still repeat, whenever the network interferes and you are cut off, please don't tune out. Stay on. I'll simply boost the network. I have my own way of trying to do that. I'll boost it to see once the network connects back after I boost it, you will be automatically connected back. You'll be logged in back. Please, you want to be patient. Remember, the journey to success is not all bed of roses. You must be dogged. You must be tough. And don't allow some little things to frustrate you. So welcome back. I hope the network is behaving now. Welcome back. I had said something earlier that whenever you are studying something, there is always a major area of focus. You don't play with that. And as we kick off this 2025-2026 academic session, whenever I teach you certain things, I will emphasize and appeal to you that you see this particular thing, don't joke with it. If you want to understand that topic, you want to understand that course and appreciate it, this particular simple thing, make sure you give serious attention to it. You know, the reason is this, my dear friends. Many times when it comes to our academic work, you see students, we are so bothered, disturbed about, some things we feel they are higher. It's not always like that. Most times what will help you to understand a particular topic is just one small thing. And so I'll be pointing and highlighting them. Please, in your own personal studies at home, from wherever you are connecting to this class from, don't joke with those things. Don't. Is that okay? All right. Let's move on, please. Let's move on. And once again, I hope the network is still on. Sorry, I am going to always check to be 100% sure. Hello, sir. I am MBBS student from India. Wow, medicine student, you're welcome. You're welcome to join us. All right. So, fundamental quantities, we defined it earlier before the network interfered. And I have this message for you. I was sent by an organization. I was sent by an organization. They said I should tell you this. The name of that organization is International System of Quantities. ISQ. ISQ, just like we have a UPAC. We have that in chemistry. Okay, here we have ISQ, the International System of Quantities for physics. I was told to tell you, don't ask me where I met them, okay? Just receive the message. I was told to tell you not to joke with fundamental quantities. That they have identified only 7 fundamental quantities for you. And that these 7 fundamental quantities will form your foundation of physics. That you should please not take them for granted. They said, if you take them for granted, it is going to affect you negatively in your study of physics. And of course, science by extension. So I have delivered this message from the ISQ, and I hope you accept it and will work in line with it. In the study of physics, fundamental quantities, they form our basis. From there, we now start expanding and expanding. So the 7 fundamental quantities we are going to mention, please make sure you do not play with them. But before we move on to state the 7 fundamental quantities, I would like us to quickly define derived quantities so that I can now wipe the board and list these quantities quickly. There is no time. This is just a 1-hour class at most, if not for network problem. So let us define derived quantities first, since we've defined fundamental quantities. Although I didn't give you examples because there is a way I usually approach the teaching of this concept so that students can appreciate it the more. We define each of them separately before we start looking at their examples, okay? What are derived quantities? Already you should have the idea if you joined the class from the beginning, because I gave the idea already. The word derived means obtained, gotten from. So derived quantities are those physical quantities whose definition or derivation depends on fundamental quantities. They depend on what? Fundamental quantities. Sometimes we can also define derived quantities as quantities that depend on fundamental quantities or on other derived quantities. I take that again. Sometimes we can define derived quantities as quantities that depend on what? Fundamental quantities or other derived quantities. But remember the first definition I gave to these quantities, derived. I simply say these are quantities that depends, whose definition or derivation depends on fundamental quantities. And that, of course, is the absolute sense of what derived quantities are. If for any reason anybody or a textbook chooses to define derived quantities as quantities that depend on fundamental quantities and or other derived quantities, it's important for us to understand that saying it depends on other derived quantities, those derived quantities are still dependent on fundamental quantity. So imagine that I have A, for example, as a derived quantity. And this derived quantity, let us say it depends on X as fundamental. And it also depends on P as derived quantity. Okay? Now, this derived quantity you are seeing, which depend on X that is fundamental, and also depend on another derived quantity that is P here, it is important for you to know that when you start breaking down P, this P will depend. P will also depend on fundamental. P will also depend on what? Fundamental. So, at the end of this all, this derived quantity depends on this fundamental quantity X, and also, although this P is derived, but the P itself depends on fundamental quantity. So that at the end of everything, however you are defining derived quantities, whatever you are saying about it, derived quantity simply depends on what? Fundamental quantities. So take note of that. Take note of that. All right. Let's check the network situation. Good. It is still on. Schlock right, quantities derived from fundamental quantities. That's correct. That's good. You are still in line with derived quantities. Are you following right? Now, I want to encourage you, friends, please. Whenever you are reading a textbook, you are reading a context, or someone is saying something, just try to interpret the real meaning of that thing. You see, in the field of science or even arts, when it comes to learning, it is not compulsory for you to get that point word by word. Once you understand the concept, being that you can speak and, of course, understand English, on your own, you may select your words on how to, define or how to present that term. You can on your own, okay? So, having said that, we have defined fundamental quantities and derived quantities. Simply put, let's go one more time. Fundamental quantities, also called base quantities, are those quantities that do not depend on other quantities for their definition or for their derivation. They do not. So that do not depend. Very important. Highlight it. Then derived quantities are simply quantities that depend on fundamental quantities. Quantities that are derived from fundamental quantities. Quantities that are defined from fundamental quantities. We are now going to take fundamental quantities and discuss briefly. We are going to take fundamental quantities and discuss briefly. Let us look at fundamental quantities. Fundamental quantities. Remember that fundamental quantities are also called base quantities, like I said. Okay? Fundamental quantities. What we are going to do now is to establish fundamental quantities like the International System of Quantities identified 7 of them. We are going to list the 7. We will list their SI units, System International Units. Units are simply standard values given to a particular quantity. Take note. You can put it down. Units are standard values given, attached, attributed to a particular quantity. So you see, whenever you hear of units, those things, they are quantities, they are numbers, right? They are numbers, they are standard values, rather. They are values, they are numbers. Units are values, units are numbers attached to a particular quantity. These numbers, we say they are standard. That is why, for example, let me mention one. You could hear something like centimeter. Centimeter is just 1/100. You could hear something like meter, and they will tell you that 1 meter, that value 1 meter, is the same as 100 centimeter. You could hear something like kilogram. Kilo is 1,000. Are you following, right? So that's it. Now, we have 7 fundamental quantities, which, like I said, the International System of Quantities have identified. And they said that any student that is aspiring for science is expected to know these 7 fundamental quantities. I'm sorry to say that it is a must. So it's a must. Like, you should have these 7 fundamental quantities in your brain without forgetting. Let us assume that you are in a dream. You are in a dream and enjoying first-class airplay, flying from one country to another country where you want to carry out adventure. You want to go and enjoy yourself. And someone just come and taps you, and get up. Mention the 7 fundamental quantities. And when the person says you mention the 7 fundamental quantities, you just open your eyes and why are you disturbing me? I'm enjoying my trip to so country. The 7 fundamental quantities are, you just say it without stress. This is how you are meant to learn the 7 fundamental quantities. Please. Because without these quantities, it will now become a challenge. You will now be having problem with derived quantities. And once a science student starts having problem with fundamental quantities, which will now stretch to derived quantities, before you know, entering the aspect of motion, all right, the aspect of equilibrium, the aspect of electricity, gravitational field, magnetic, and the rest, like everything will just be going left. You'll be confused. So please, this little class we've decided to host this morning, from here, make sure that you are able to learn your 7 fundamental quantities very well. Give yourself at most 3 days. 3 days is sufficient. You learn them very well with their SI units. The first one I'm going to give to you is mass. All right. I want to put it in table form. Let me see, but I'm not going to draw all those lines. Let's have quantities. Quantities, and then we are going to have SI unit, the System International Unit, right? I hope this doesn't cut off from view. SI unit. So the first, number 1, is mass. The SI unit of mass is kilogram. We have other smaller units, but the generally accepted unit in the universe is kilogram. Some country will be quoting something like pounds. I think the English people, right? England, the Europeans, they usually quote in pounds. Americans also quote in pounds or something like that, okay? But that is just other unit. The generally accepted unit in the universe for mass is kilogram. That's why we call it SI, System International. Number 2, we have length. SI unit of length is meter. Meter. We have other smaller unit like centimeter, millimeter. We have a bigger unit of it, kilometer. But the generally accepted standard is meter. I hope the network is still showing, right? Okay. The third actually is time, which is second, but let me check the network situation. All right, we are still on. Schlock, right? I am scared of rotational motion and equilibrium. Don't worry. That topic is 1 plus 1, okay? That topic is what? 1 plus 1. Reels unfolded. This is our sleeping time. No reading, please. PW, different country. All right. I know that depending on where you are connecting from, we may have different time. Okay, this is Nigeria. I think the time now from Nigeria is 10:46 a.m. All right, that is 14 minutes to 11 o'clock. All right, morning. So manage up with us. If you are in the dark over there, maybe at night, and you still want to learn, you can join. It's just a 1 hour class, and that's it. Okay, we are moving on to the next one. Number 3, we have time. The SI unit of time is second. Number 4, we have current. The SI unit of current is ampere. Look at this time, second. There are other units of second like the hour, all right, like the minutes. But the generally accepted units around the world, the universe, the SI unit is second. We are using their symbols to represent them. You may decide to write the full name, kilogram, okay, meter, second, ampere. This A here is ampere, A-M-P-E-R-E, okay, ampere. Number 5, we have amount of substance, amount, simply for short, amount, or you can refer to it as amount of substance. We meet this quantity often in chemistry. We don't use it in physics. You hardly encounter this amount like that. But in chemistry, we use it a lot. That quantity we call the mole. The mole. Yes. Amount of substance. The unit is mole. M-O-L. The unit is mole. Then number 6, we have temperature. Temperature, or you can call it thermodynamic temperature. Temperature for short, or you call it thermodynamic temperature. Let me write it, thermodynamic temperature, dynamic temperature. Okay, if you still want to simply call it temperature, the choice is yours. The SI unit is Kelvin. Kelvin. We have other units of temperature like the degree centigrade or Celsius. We have the degree Fahrenheit. Degree Fahrenheit. But the SI unit, System International, the generally accepted unit is Kelvin. Finally, we have this quantity called luminous intensity. Luminous intensity. Luminous intensity. What is the SI unit of luminous intensity? It is candela. Candela. CD, candela. This is the SI unit of luminous intensity. This one usually deals with the rate of light, okay, the intensity of light. Luminous has to do with light, okay. What quantity of light is reaching a particular surface. That's the luminous intensity of that light. The unit is candela. So dear friends, the other ones I've told you can write their full name if you want. Kilogram, meter, second, mole. The full write-up of this mole is M-O-L-E. But in terms of the SI unit, you abbreviate it as M-O-L. Kelvin, K-E-L-V-I-N. Then candela. These are the 7 fundamental quantities that the International System of Quantities, responsible for having approved this quantity, they said, please, any student, it doesn't matter. Let us assume you are just entering grade 10. Which in Nigeria here we call it SS1. From grade 10, senior class upward. Okay? You are expected to know this and know them very well. In your professional examination, like in Nigeria here, we talk about JAM, we talk about WAEC, we talk NECO, right? You have your GCE. You don't play with these. Exam bodies will ask you questions on them. And if you really want to start enjoying your physics study, your science, this is the starting point. You want to know these 7 fundamental quantities and their SI units. Because these are the beginners, the originators, the base, the fundamentals, the foundation. They give birth to other ones we are going to meet. There are no 2 ways to this. You are simply expected to memorize them, cram them. Because these are standards that have been set out for you. You don't need any formula to define them. They're on their own. Let's go. Mass, SI unit kilogram, length, SI unit meter, time, SI unit second, current, SI unit ampere, amount of substance, SI unit mole, thermodynamic temperature, simply temperature, SI unit Kelvin, and we have luminous intensity, SI unit, candela. Learn them, memorize them, cram them. It is now time we are going to talk about derived quantities. We shall find out how these quantities are obtained from fundamental quantities. You can screenshot this as fast as you can, or if you're not able to meet up in your write-up, because you're meant to be copying some of these things, right? At the end of this class, a copy of this live class will be made available. You check under the live section of this channel. Now, if you come to a particular channel, you have something like shorts, video, live, playlist. So since this is a live class, just come to the live session, tap that live, and all our live classes will appear. There are so many of them that we have conducted. So you can still take this lesson again, okay? Where you can pause, copy notes. You can fast forward some things you already understand. You can slow some things to understand it better if you have challenges in them. That is at the end of the class anyway. Let us move on to derived quantities and how we obtain them from fundamental quantities. And of course, that's going to be the end of the class. These are the key things you're expected to know. Let me check the network situation. We are moving. Please, once you join the class, what stops you of hitting the like button? Like this live class. What is happening here is not easy. Yes, I say it's not easy because GMAETS 41 tries to always give the best ahead to students. It is absolute integrity, commitment, and consistency which always produce results. I could tell you my university student is in 100 level, and of course my other students in secondary school, as we call it in Nigeria here, those that take professional examination also, you can see excellent results they make. Excellent. I'll soon release a package of it. Yes, I'll soon release a package of it so you see what we perform. And let me tell you, it is not magical. There are no two ways to it. You just want to take your work seriously and work ahead of time. That is the simple truth. Because once you resume school, a lot of pressure, stress will be on you. By the time you run up and down, do this, do that, lectures will come and you just get so confused. So when you learn from the comfort of your home like this from GMAETS 41, where the truth remains that everything in your textbook, in your course outline, they are being broken down 1 + 1. Area of importance is being highlighted for you. You understand that by the time you enter classes, you'll be smiling when they are teaching you this. And you'll be like, yeah, GMAETS is trying. So please like this video and then share it to your friends. Encourage your friends to join our classes. Encourage them to subscribe. If you have not subscribed, please kindly hit the subscription button. And remember to be able to access all our classes, because sometimes even our live class may just be meant for members only, become a channel member. Now, start joining GMAETS 41 on the diamond level. It's a monthly package, okay? It's a monthly package of 4,000 Naira Nigerian currency. So if you are not in Nigeria, you can check the conversion from 4,000 in Nigeria to your own currency. How much will it be? Support the platform with that so that you can learn fully, okay? That will help you to access members only video, members only class. We are moving on. Let's conclude with derived quantities. Derived quantities. Derived quantities. Now, under these derived quantities, we are going to look at the quantities. We are going to talk about the quantities. We are going to look at their derivation. Derivation. How do you derive them? How do you derive them? Their definition. And then we are going to look at their SI unit. I hope this does not cut off. We are going to look at their SI unit. Fundamental quantities are just seven, only 7 fundamental quantities. And let me tell you, fundamental quantities are far more important than derived quantities. Why did I say so? because you need fundamental quantities to be able to learn derived quantities. But this is where the whole thing gets a bit messy, a bit troubling. But you can do it. You can do it because God has already given you the knowledge to do it. Have that confidence. Now, where did this whole thing in derived quantity get messy, get troublesome somehow? You see this derivation? This is where it becomes much more messy. Because you need to know their formulas. The derivation is the definition, is the formula of that derived quantity. You need to know their definition, their derivation, their formula. So you now have to start working from the few we are going to consider today. And then when we start moving on in other topics, if we mention any quantity, we will talk about the formula, the derivation. That is if that quantity is derived. We'll talk about the formula. And then from the formula, you can now determine the SI unit. So dear friends, you need a lot of work here now as it is. But the idea is that you want to make sure you remember their formulas. And this is not something you do one day, please. So don't go overstress yourself. Don't punish yourself unnecessarily. Make sure you are following gradually. Anytime you are being taught any science subject, science course, if a quantity is being mentioned, try to find out the formula of the quantity. Now, if that quantity is not fundamental, if it is not among the 7 fundamental, automatically it becomes derived. Automatically it becomes derived. So if you know the formula, your problem is solved. You can now get the SI unit. Let me check that this did not cut off, and also the network situation before we start. Oh no, it cut off a bit. Cut off a bit, so let me adjust. Good. So the very first derived quantity I want us to look at, area. Area is equal to, the derivation of area is length times breadth. Length times breadth. Length times breadth. It could be length times width. It could be length times height. It could be length times thickness. The reason is because you see length as a fundamental quantity. If you hear length, if you hear thickness, if you hear breadth, if you hear height, they are all length related. Any quantity that is mentioned anytime, listen to the secret now. Any quantity that is mentioned anytime, and that quantity is something that is about distance between 2 points. You know, if I have a point here, I have a point here, you have a distance between them. So if I mention any quantity, and that quantity, you know, is simply the idea of moving from one point to another point, automatically that quantity becomes fundamental, because that quantity will be length related. I'm going to give you an example. Look at this, a meter rule. This is a meter rule. From this point to this point, you have 2 points. This is 1 point, this is another point. This gives you height. Height is simply length related. This height you are saying and is the length from here to here. So if you hear of height, height is a fundamental quantity because it is length related. Let me turn this meter rule this way. If I turn this meter rule this way, you see we now have what is called distance per se, because if I move from this point, this is 1 point. If I move from this point to this second point, I've covered the distance. That distance is simply the length from here to here. Because when somebody is talking about distance, you have to move from 1 point to another point. And like I said, whenever you have a length between 2 points, that thing is fundamental. That thing is length related, like that quantity is length related. So from here to here, you talk about a movement along the horizontal. Movement along the horizontal is length. Vertical is height. You can use distance to refer to both of them. Distance. So distance is length related. Height is length related. Now look at the thickness of this meter rule. From here, from here to here, is the thickness of the meter rule. Look at it. If you are holding this meter rule up, maybe simply hold your pen or your book, hold it this way, the thickness. You notice that this is 1 point, this is 1 point, and this is another point. So this is actually a length between 2 points. A length between 2 points to give you thickness. It will give you width. Now look at the width of the meter rule. The width, you can see as I'm holding it, which is from here to here. Width is also distance between 2 points. So width is length related, which means it is also fundamental quantity. I'm saying this because in the list of fundamental quantity, you only met length there. There is nothing like height, thickness, width, breadth, distance, displacement. You didn't see or hear any of such. But I want to make sure that you know that all these things I mentioned, you can put them down now. Height, distance, thickness, width, breadth, displacement. They are all distance between 2 points. So they are length related. Therefore, what defines them in the study of quantity is length, making them fundamental. Area is length times breadth. Like I said, breadth is also length. So how do we get the SI unit? Simple. It's going to be the SI unit of length times the SI unit of breadth. And you know that SI unit of length is meter. SI unit of breadth is also length related, so it is meter. So you multiply meter times meter. And if you have meter times meter, it will be how many meters? 2 meters. Since you are multiplying them, according to indices, laws of indices, multiplication law, you have meter, you are multiplying them. Pick one of meters and then power 2. Power 2, because there are 2 meters and you are multiplying them. This is the formula of area. This is the SI unit of area, pronounced as square meter. That's the correct pronunciation. Sometimes you could pronounce it as meter square. It's okay, but it's correctly pronounced square meter. We are going to look at volume next. Number 2, volume. Volume as a derived quantity. The formula, the derivation of volume is length times breadth times height. Now all these quantities, 3 of them are length related. So how do we get the SI unit? It's going to be the SI unit of length, which is meter, times SI unit of breadth, which is meter, times SI unit of height, which is also what? Meter. How many meters? 3. And you are multiplying them. That is meter times meter times meter. Multiplication law of indices said you should pick one of the meters since all of them are the same. Then you write the number of meters you have. There are 3 of them. Write it as power. So this is cubic meter or meter cube. Correctly pronounced, like I said, would be cubic meter. But sometimes we call it meter cube. It's still okay. Meter raised to power 3. Are we following, right? Let me check the network situation. All right. Screen is not aligned with camera. I think it's aligned now. I think it's aligned. Okay. So we move on. The next quantity I want us to talk about is density. Now that we know volume, we can actually talk about density. We can use symbols for these guys, like area. Area usually is capital letter A. Volume usually capital letter V. Density, we can use rho, this symbol for it. Are you getting me right? Okay, let me just be applying certain symbols. Okay, good. You can use any alphabet you want to represent the quantity. The choice is yours. Area capital A, volume capital V, density density. This symbol is a Greek symbol. Pronounce it as rho. Okay, let's move on. What is the derivation, the formula of density? The derivation is mass divided by volume. Mass divided by volume. That is the definition of density. You can now see where your attention is fully needed. The formula of these quantities. The formula of these quantities called derived quantities. Now, someone may be like, how will I know? These things, there are so many. Because, of course, derived quantities, we don't have the lists. It is not like fundamental quantity that are just 7. Derived quantity, the lists cannot be exhausted. There are so many of them. So we can't even list as many of them as we have. We only list a few of them. But I've given you the idea. As you're now studying physics, once you hear any quantity and it has a formula, ask yourself, that quantity, is it among the 7? Is it among the 7 fundamental quantities? That quantity that has a formula, is it among the 7 fundamental quantities? If not, it means that that quantity is now derived. Then you have to cram. There are no two ways about it. When it comes to formula, dear friends, it's for you to memorize them. If you know the definition, like density is defined as the mass of a substance occupying a given space. So we simply define as mass per unit volume. From that definition of density, mass per unit volume, per, in mathematics is divide, per, PER. In maths is divide. So we apply it in chemistry study, in physics study. So if we define density as mass per unit volume, mass, N, per, divide, volume, denominator. You have gotten the formula. So are you worried? How will I know all this formula? Calm down. For those that are just entering grade 10, in Nigeria we call it SS1, your journey just started. For those that are entering 100 level in university, higher institution, colleges of education, polytechnics, monotechnics, your journey is just going to start from either September or October. You don't need to panic about this. We have laid the foundation. When you are moving on, you'll be learning several of these quantities. And like I said, once any quantity is mentioned, quickly ask yourself, is this quantity among the 7 fundamental quantities? If no, that quantity becomes derived. So what do? Memorize the formula after you understand the definition. So it is a gradual process. The only thing is, don't play with them anyhow. Like you just learn them, you are being taught, and before you know, you just neglect them. No, keep studying them. Keep studying them. When you are walking on the road or doing something, you are in the car, moving to somewhere, or in any mobility stuff, you can be thinking about these things. These are the ways you remember them. Have I communicated? I know as many of these things. I was not born with them. I learned them gradually. The more they are coming, the more you are putting them here. The more they are coming, the more you are putting them here. But you need to work. You need to study them regularly. The SI unit of mass is kilogram. The SI unit of volume is cubic meter. So, to get the SI unit of density, you are going to use the SI unit of mass, which is kilogram, per, or divided by the SI unit of volume. And this is how we write it. Mass is kilogram. This division sign will now be written as per. You know, this is divide. Yeah, it's also divide. Cubic meter for volume. Look at, for volume, cubic meter. Cubic meter. Or you can express it as, you see, this thing is kilogram per cubic meter. If I want the meter cube to go up, so as to multiply this kilogram, for this denominator meter cube to now become numerator. Once this m raised to power 3 is going up, from denominator is going up, the sign of this 3 of the power will change. See, the power here is plus, positive. That is why there is no minus there. This is m raised to power positive 3. If it goes up now, so as to remove this division sign, the sign of that plus will now change to minus. So we can write this as, or, let me write it, or here, or kilogram, then multiply it, write the meter. That power 3 will now become minus, to change. The same way, if I want this m raised by minus 3 to now come as denominator, no longer multiplication, between this kilogram and this m, there is times, but you don't write that times. Look at it, kilogram times meter raised to power minus 3. But if you're writing it in SI unit, you don't show these times. You don't. Take note. Just combine them. Besides, we know that xy is the same as x times y. Are you following? So you don't need to be showing the times whenever you want to write it. It's only division that we write as per. If you want to write the SI unit in terms of division sign. So we move on. Let us look at number 4, another quantity. Can we talk about speed? Let's talk about speed. Speed. We are going to use small v for speed. The definition of speed is distance over time. Distance over time. And so to get the SI unit of speed, you obtain it from the SI unit of distance divided by the SI unit of time. Okay? I was going to say something here earlier, please. I just forgot when I was writing. If you want that meter raised per minus 3 to come down as denominator, no longer times, it will be kilogram over, or you write per. Since this m is coming down now, the sign minus 3 will now change to plus 3, giving you kilogram per cubic meter. Are you following? So the idea is simple. If denominator or numerator is changing position, maybe numerator wants to come to denominator, the power of that numerator the sign will change. If it is plus in numerator, the power will now become minus in denominator. If it is minus in numerator, coming down, it will become plus in denominator. The same thing, if you are taking anything from denominator to numerator, the sign of the power will also change. If in the denominator, the power of that quantity is positive, for example, if it goes to numerator, the power will change to negative, minus. If the power in the denominator is minus, if it is going to the numerator, it will change to plus. So all these little things are critical aspects of your studies you don't want to joke with. Always remember that. We are talking speed now. Speed is distance over time. So what is our distance? The unit of distance is meter, like I told you, because distance is length related. So it's going to be meter divided, and that divide is per. Time, the unit of time is second. Or you can write this as, I want that second to go up now as numerator. The power of this s, there is no number written here as power of s. Since there is no number, it is invisible 1. Any quantity standing alone is raised to power 1. Any unit standing alone is raised to power 1. Any number standing alone is raised to power 1. If there is no power on it. So this s here is raised to power 1. So if this s is going to numerator from the denominator, it's now going to be meter times second. The power 1 will now change to minus 1 because in the denominator, it is positive 1 plus 1. If it goes to numerator, it will become minus 1. This division sign will be removed. You have your multiplication. The raised to power minus already explains why the division disappeared. Let's check the network situation and be sure as we round off. Okay. So let's look at the next one, velocity. Velocity. Again, velocity, we use v for it. And what is the definition of velocity, which helps us to get the formula, which helps us to get the derivation? Velocity is defined as displacement over time. So this is going to be displacement divided by time. Interestingly, the unit of velocity is the same as the unit of speed. Let's find out. What is the SI unit of displacement? Now, if you take your mind back to fundamental quantity, you will agree with me that displacement is length related. Because if something is displaced from this point to another point, if you say somebody is displaced, it means that object, that person, that particle, that body moves from one point to another point in a particular direction. So the SI unit of displacement is meter divided by the SI unit of time, which is per SI unit of time is second. Or you can see it as meter then times second raised to power minus 1. This is still pronounced as meter per second. That raised by minus 1 makes it per. Number 6. Let's look at acceleration. You see, I decided that we should look at motion quantities. Motion, very important. Acceleration. What is the definition of acceleration? Acceleration is defined as velocity over time. Velocity over time. Now, what is the unit of velocity? Because to get the unit of acceleration, it's now going to be unit of velocity divided by unit of time. Now, you see, acceleration is a derived quantity because it is not among the 7 fundamental quantities. It's not. So it is derived. Now, look at the definition, the formula of acceleration. Acceleration is velocity divided by time. You remember that when we were defining derived quantities, I told you that derived quantities generally are quantities that depend, that are derived, that are obtained from fundamental quantities. Simple. But sometimes you could hear someone in a textbook derive or define rather derived quantity as quantities that depend on fundamental or other derived quantities for their definition or derivation. It's all good. But like I said, even if a derived quantity depends on another derived quantity, that derived quantity it depends on is on itself dependent on fundamental quantity. So that at the end of everything, that derived quantity we are trying to get is simply dependent on fundamental. Look at what I'm trying to explain here. Acceleration depends on velocity and time. Velocity is derived quantity. And then time is fundamental. So it is as simple as acceleration depends on derived quantity and fundamental quantity. But hey, look at this velocity that is derived. From number 5, we find out that velocity depends on displacement and time. Displacement and time are both fundamental quantities, which means that this velocity you are seeing here is gotten from fundamental quantity. This velocity depends on fundamental. So in all, acceleration depends on fundamental and fundamental. That's what I was trying to explain in that definition. Let's move on. To get the unit of acceleration is going to be unit of velocity divided by unit of time. What is unit of velocity? We have it here, meter per second. Written like this or written like this. That is just for velocity, which means in the numerator I'll write meter per second alone. Now remember that this is divided by time, bringing another second in the denominator. Let me show you. This is what we mean. Meter per second for velocity divided by the unit of time, second. Meter per second defines unit of velocity, and then this second under defines for time. Now you notice that we can take this second up. If we are taking this second in the denominator up, what will happen is simple. The power of this second in the denominator, which is invisible plus 1, because there is no power there, invisible plus 1. When it goes up, that 1 will change to minus 1, which simply means if I write the numerator meter per second, this second going up, since there is a second on top, all you just have to do is simple. All these things are principles of indices in mathematics. The power of this second in the numerator will simply go to the power of the second in the numerator. Since the power here is plus 1 in the denominator, if it goes up, it will become minus 1. It will become what? Minus 1. So that in the numerator, you're having minus 1, minus 1. And minus 1 will give you minus 2. Minus 1 will give you minus 2. So the acceleration SI unit is meter per square second. Per square second. Remember, if this second is coming to denominator, it will be written as meter, this S, put all over. This times here will change to all over. The times between meter and second will change to division. Then the second will come down to denominator. The minus 2 will now become plus 2. That is this meter per second. Or per square second rather, per square second. Or you can write it just the way I showed it here. Meter per square second, written this way or written this way. This is the SI unit of acceleration. Now I'm going to check on the network, and then we'll quickly look at either two other quantities. We'll talk about force, we'll talk about work, and then think that will be that for this class. Let's check the network condition as we conclude. I don't know, it seems like the network interfered a moment. Sorry. But we can see all this. There's nothing that is there. They are simple concepts. I've just explained that of acceleration, velocity over time. Velocity is meter per second on its own. Then over time, time is second. If this second is going up, since we have another second in the numerator, all you just have to do is take the power of the second in the denominator to go up. And if it is going, I've told you the power sign will change. Denominator here is positive 1. If it goes up to meet this one, it becomes minus 1. So you have meter second raised to power minus 1, and this one going up also will be minus 1. If you do minus 1, you will get minus 2. So the unit of acceleration is either written this way or this way. That's what I showed you, meter per square second, or written in this format, still pronounced meter per square second. Like I said, we are going to conclude with the SI unit of force and work. Very important. SI unit of force and work. Let me wipe this. Remember, if you have not copied the notes, like I said, at the end of this live class, a copy of this live video will be made available. So come back to it where you can watch it as a video, all right, as an uploaded video, and you can make your notes from it. Number 7, force. Force. Use F for force. What is the definition? Which hence gives us the derivation of force. And of course, if you know the definition, you can now derive the formula. Force is defined as the product of mass and acceleration. So force has the formula mass times acceleration. Mass times acceleration. So to get the SI unit of force, we will obtain it from the SI unit of mass and the SI unit of acceleration. We know the SI unit of mass already to be kilogram. So I will write kilogram as the SI unit of mass times, but you don't need to show the times in the SI unit. You don't do that. It's only per division that we show there if you want to. Acceleration, the SI unit is meter per square second. Look at it. So this is going to be kilogram times meter per square second. Or, you can write it as kilogram meter. This per square second, if that second square goes to the numerator, the power positive 2 plus 2 will change to power minus 2. So this becomes meter, then per second, written like this. You want to take note of this. Take note of this. You see this SI unit of force, kilogram meter per square second. Together, we call it the Newton. We call it what I said, the Newton. So all these things you're seeing here is called the Newton. Let me write notes. Notes. I'll just fix all. This whole unit you're seeing is called the Newton or Newton. Let me write it in word. The symbol we use for Newton is capital N. So you want to take note of this, please. You want to take note of this. 1 Newton or 1 kilogram. 1 kilogram meter per square second is equal to 1 Newton. 1 kilogram meter per square second is the same as what? 1 Newton. So you want to take note of that. Now your examiner can ask you a question like this. Which of the following SI units is the same as the Newton? And the correct answer will be kilogram meter per square second. Or you are asked which of the following SI units is the same as the kilogram meter per square second. And the correct answer will be the Newton. I hope you followed up with this explanation, please. Very important. Very important. The network is just cutting and cutting. Let's see. Let me boost it a bit. No, it's not funny. The network challenge, right? Just talked about force. And I told you SI unit of force is kilogram meter per square second. It's the same as the Newton. And you want to take note, generally for force, the SI unit we use is Newton. You hardly see it as kilogram meter per square second. But in terms of trying to derive it, it's actually kilogram meter per square second. But that kilogram meter per square second is the same as the Newton. We use the first letter of Isaac Newton, who studied the concept of force. We use that Newton N as the unit, the SI unit of force. So take note, like I said, if you are asked which of the following SI unit is the same as the Newton, the answer will be kilogram meter per square second. Or you are asked which of the following SI units is the same as the kilogram meter per square second. The correct answer will be the Newton. Let's go to work quickly. At least we've been able to defeat the network interruption. I love this. Like I said, at GMAT 41, we don't give up. We are not affected by these things. We keep pushing and fighting. Work. Please take note that the SI unit of work is the same as the SI unit of energy. Is that okay? The SI unit of work is the same as the SI unit of energy. So permit me, please, since we wouldn't have enough time again to talk more about my proving why the SI unit of work and energy are the same. But let's say in one of my fun YouTube short video, I'll just do that. So make sure you follow up with all of our updates. If you have not subscribed, please click on the subscription icon. Do that now so you don't forget. And after you subscribe, you will see the bell icon there. Click on that bell icon so that you will select all. If you click on the bell icon, a menu will drop out like all, personalize, another thing. Click on that all. Automatically, once you click on that bell icon, you will see personalize highlighted for you. Please change it to all. The reason is this. You're not paying anything for that. Take notes. YouTube has that arrangement so that once a creator uploads any content, you will be personally informed, notified by YouTube that something is on. So you won't miss out on any of our classes. Work. Generally, work is defined as force times displacement. Force times displacement. Force times displacement. Sometimes some people define it as force times distance. Well, it's okay. But it's generally by standard force times displacement. Is that okay? Now, what is the SI unit of force? Newton. Kilogram meter per square second. Okay, no problem. But it's Newton. Like I said, that's what we use to represent it. What is the SI unit of displacement? Meter. Because displacement is length related to fundamental quantity. So combining this product, this multiplication, force is Newton times displacement is meter. So the SI unit of work or energy is Newton meter. Newton meter. Now take note again, just like I introduced Newton to represent kilogram meter per square second or to be the same as kilogram meter per square second. For Newton meter, which is a unit of work or energy, we have a standard representation for it. So here I am going to say or joule. Joule. In bracket for joule, we use capital J for it. What does that tell us? You want to take note. Note, please. Here I said you should note for the case of force. Note. For the case of work or energy, 1 Newton meter is the same as 1 joule. They are the same units. So if your examiner asks you which of the following SI units is the same as the joule, the correct answer is Newton meter. Or you are asked which of the following SI units is the same as the Newton meter, the correct answer is the joule. I think this is the point we are meant to stop. But I feel like concluding with power. I feel like concluding with what? Power. Let us introduce power, please. Power, we're using P to represent power. Work, we are using W to represent it if we wish. And then energy, you can use E to represent it. What is the definition of power that gives us its derivation and or formula? Power is defined as the rate of expending energy, the rate at which work is done. So by the formula, it is work over time. Because when we talk about rate of anything, it is that anything over time. Rate of anything. Rate of GMAETS 41 is GMAETS 41 over time. Rate of you, dear student, is you, dear student, over time. No wonder we talk about the rate of change of velocity, for example. Rate of change of velocity under motion is velocity divided by time, which defines acceleration for us, as you have learned already, because I told you acceleration is velocity over time. Rate of anything is that anything over what? Time. So power is the rate of doing work, the rate at which energy is used. On the basis of that, it is energy divided by time, energy or work over time. I hope this does not interfere here. Let me bring that definition down, because the Newton meter is for energy. Power, number 9. Power. We are concluding already, like I said, energy or work over time. This is the last derived quantity. There are so many derived quantities. Take note, we cannot exhaust the list. So GMAETS 41 has exposed you to this concept of derived quantity. I am sending you out now to seek for your textbooks. During your lectures, your lessons at school, pay attention to quantities being mentioned. Go and find out their formula. Once you know their formula, get the SI unit of that quantity from the formula. Like I said, all of these things, they are dependent on fundamental quantities. Let's conclude. Energy or work over time. We know the SI unit of energy already. We are using joule. The joule is the standard used for it, although it is the same as Newton meter. But oftentimes we use joule instead of Newton meter. So it is going to be joule divided by time per. Remember, in SI unit division, we use per for rate. Time, the SI unit of time is second. So you can write it as or joule per second this way. Where that S we go to numerator, it becomes -1. You see this joule per second. It is the same as the watt. It is the same as the what? Watts. Which means 1 joule per second is equal to, is the same as 1 watt. So let me put it down here, or we call it the watt. The watt, in bracket we use W for watts. We use W for watt if you want. Does that make sense? So remember, 1 joule per second as the unit of power is the same as 1 watt. So if your examiner asks you which of the following SI units is the same as a watt, the correct answer is joule per second. Or you are asked which of the following SI units is the same as joule per second, the correct answer is the watt. And this is how we've come to the end of our introductory first physics class for the 2025-2026 academic section. Remember, this section is yet to come. From September, October 2025, that session begins. But you see, GMAETS 41, we have activated in order to start training the young ones, either those entering, grade 10 and then moving up, and or those entering 100 level in university. If you're in grade 11, grade 12, in Nigeria, here we call it SS2, SS3. Remember, you need this and need it a lot. Some of us, somehow, some way, have forgotten it. Some of us, somehow, some way, we were not even taught at all. Even those entering university. These are chances. You have the opportunity to have learned this again. Because your professional exam bodies will test you on them. There are no two ways about it. I'll be seeing you in our next class. Next physics class, we are going to be looking at dimensional analysis. Remember, we have a timetable guiding us on this. Look for it in the community section of this channel. If you come to the home page, you would see, is it visit or view community? Tap on that community, right? Tap on that view community or visit community. You would see the GMAETS 41's update. You see the timetable that guides us here on this particular 2025-2026 online lesson that we've kicked off. So you know what we have in a particular day. This is just the first kickoff class, okay? I'll be seeing you in our next class. But like I said, subscribe, turn on the notification bell, select all, so that once I upload any content or I come on live, you will be the first person to be notified by YouTube. Share this video to your friends and encourage them to also subscribe and follow us on this channel. Become a channel member on diamond level so you don't miss out on anything at all, especially for lessons or lectures meant for channel members. Have a lovely day. And for those of you that is in the night, have a good night rest. Bye. If you have any question, remember to drop in the comment section, okay?